Most wire assemblies are produced in the electrical department at the factory. Each build number is a recipe of wire gauge, wire length, circuit number, and terminals for one or both ends. Bulk wire from a drum is pulled past the jet printer, which prints the wire number and length every 8 inches and at blurring speed. Terminals are fed into the machine from reels. Wire is pulled through the fixture, then cut to length. As it's retracted, the insulation is stripped, the core aligns with the terminal crimped, then the wire is fed out of the machine as the process repeats. The completed assemblies are batched, then sent to the soldering stations. The terminals are soldered to the wire core for electrical and structural integrity. Wiring splices are fused by ultrasound. The wire cores are squeezed together and heated by ultra-high frequency sound waves, which fuse the cores. This method provides a superior connection and is easier to produce. Then the splice is sealed by shrink tubing. The wire assemblies are laid out on a fixture and installed into the connectors. The circuits are tested, then wrapped into harnesses. The wiring for the dash panel is assembled into the panel and tested. Prior to installation in the cab, the instrument panel assembly is bench tested by a computer which simulates driving conditions and provides a full range of sensor inputs into the instruments and gauges. This type of quality control provides best effort of reliability. This is the Packard Terminal Repair Kit, which we recommend for service repairs. The kit contains several tools, including an assortment of picks for removing terminals from connectors, 4 crimpers, 3 of which have stamped information on the jaws. This one has die positions A through E. This one has 2 dies, F and G. The splice dies are not used. This one has no stampings. It is used for crimping butt connectors and splice clips. This crimper has dies 1 through 5. A deluxe wire installation stripper is included with the kit. A portable butane torch has interchangeable soldering tips and a shrink tube heat shield. The crimp tool matrix card identifies which tool should be used for a given terminal. Don't lose this card. There are 2 hardware trays which contain various terminals, clips, and seals. The lid chart identifies the part number of a piece by its compartment location. The part number is used on the tool matrix card to identify which crimper and die positions are needed. Here's a typical wire group, but one of the wires has worn insulation. Rather than splicing in a new wire, we'll replace the terminal. Use the standard pick to remove this 56 series terminal from the connector. Match the terminal to be removed with its replacement. Carefully check that they're the same. The lid chart identifies the terminal's part number. Remove the damaged portion. and strip back the insulation about 1/4 of an inch. Inspect the wire core. It must be bright metal. If not, cut and strip again. The terminal has a pair of core wings that will be crimped onto the wire core and insulation wings to be crimped onto the insulation. Refer to the lid chart for the part number, then to the crimp tool matrix card. The part number will cross-reference with the correct core crimp die and insulation crimp die. Crimp the wire core wings first. Then the insulation wings. Pull on the terminal to check for a tight connection. Next step is to solder the core joint, which we'll cover later. 12-gauge wires or larger should not be spliced, but for simple splices of 14-gauge or smaller, a splice clip can be used. If you're not sure that a splice is permitted, refer to the troubleshooting or service manual. Strip both wire ends about 3/8 inch. Insert the clip into the die of the crimper. Insert the cores from opposite sides. And crimp. Pull on the wires to check for a secure connection. Notice that the splice clip has a hole for soldering the connection. We'll cover that shortly. During a routine inspection, one of these terminals was found to be loose within the connector. This is a micro-pack type terminal. The kit contains pre-crimped wire assemblies for difficult-to-install terminals. We will use one of these assemblies and splice it into the circuit. Line up the terminals for similar wire length, cut, then discard the damaged portion. Strip both wire ends about 3/8 inch. In some situations where other parts are to be installed onto the wire, like connectors or seals, the part should be installed prior to stripping the insulation to prevent damaging the core strands. The recommended splicing method uses a crimp splice, a solder sleeve, and heat shrink tubing. Install the solder sleeve, then insert one core into the crimp splice and crimp that end. Pull on the wire to check for a secure crimp. Before crimping the end with the terminal, be sure that any seal or connector is in place, or that the shrink tubing will fit over the terminal. Insert the other wire core and crimp. Pull on the wires to check the connection. Position the solder sleeve over the crimp splice. The next step is to heat the solder sleeve. Soldering tools. A soldering gun is good for many applications, but heat control can be difficult, so it's not recommended. The pencil-type soldering iron is recommended due to its small size and lower heat. The Ultra Torch is also recommended because of its adjustable heat range, it's portable, and it has several tip styles, including a heat shield to use with shrink tubing. A sight glass for the butane fuel is located at the top of the handle. For electrical connection soldering, a rosin core solder is needed, preferably a 60-40 lead-tin content. This solder is too large for small components. The solder on the left is the same type, but a smaller diameter and best for fine control. Place your work on something that won't absorb heat. Heat the terminal wings and wire core. Place the solder on the core and wings connection, not on the iron. If the core and wings are not hot enough to melt the solder will not penetrate the joint. The heat from the parts, not the iron, should melt the solder. Reinstall the repaired wire assembly into the connector and pull on the wire to test the terminal's lock. The torch has several controls: the gas lever, the gas on-off switch, and the shutter lever, which controls the ignition vent. Light the torch. After several seconds, the catalyst will glow and the vent can be closed. The flame will go out and the gas reacts with the catalyst, producing heat. Whenever a new soldering tip is used, the tip should be tinned to prevent scorching. Remember, the heat from the parts should melt the solder. Watch for good flow into the joint. You can reheat, but don't burn the rosin flux. A little more solder can be added. Remove the soldering tip after it cools and install the heat shrink shield. Slide the section of shrink tubing over the splice joint and seal the splice. Heat the center section of the solder sleeve until solder can be seen at the sleeve to crimp location. The ends of the solder sleeve are shrink tubing, which also must be heated. Slide the outer shrink tubing in place and seal the entire splice area. Heat the tubing until the adhesive is present at the ends. Insert the terminal into the connector and pull on the wire to test the terminal's lock within the connector. The terminal repair kit is convenient, but only if the parts are replenished and put back in their proper location, and tools stowed in the case. Quality work includes tool care.